going to talk about the alternate definition of derivative. The alternate definition of derivative. And it's actually a theorem. It's a theorem. It says that f prime of c is equal to the limit as x goes to c of f of x plus c, f of x minus f of c all over x minus c. And we are going to prove this. Now, we know that f of x, so let's write no. No, I meant to say f prime of x is equal to the limit as delta x goes to 0 of f of x plus delta x minus f of x over delta x. Okay, so f prime of c is going to equal the limit as delta x goes to 0 of f for c plus delta x minus f for c all over delta x. And now we're going to make a substitution. Delta x is going to become x minus c. So let x minus c equal delta x. Okay. Now, we know that delta x is going to 0. So as delta x goes to 0, x minus c, which is delta x, goes to 0. That means as delta x go to 0, well, for this difference to go to 0, that means that x must be getting closer and closer to c. So we have equals the limit. So instead of delta x going to 0, I'm going to say x goes to c. And in the bottom, instead of writing delta x, I'm going to write x minus c. And the nice part here is I have minus f for c. Okay. So now, what is c plus delta x? Well, let's just solve this for c plus delta x. So x minus c is delta x. If I happen to add c to both sides, I get x can be replaced with, that's what equals means, can be replaced with delta x plus c, or c plus delta x. C plus delta x. So I have an f, I'm going to put an f, and instead of c plus delta x, I'm going to write x. And you go, wow, look at that. F prime of x does equal this. Now, just want to talk about this alternate definition for a moment. So we have a formula for f prime of x, f of x plus delta x minus f of x over delta x, and we have a formula for finding derivative at a point, straight up, just at a point. It's f of x minus f of c over x minus c. Now, if you had two problems, one, find f prime of x, and here it is for x equals 2, here for x equals negative 2, and over here for x equals 7. Now, one way of finding the derivative at x equals 2 is to use this formula. In other words, you can just go f prime of 2 is equal to f of x minus f of 2 over f of 2 over x minus 2, and I meant to write the limit as x goes to c, which is 2. And I realized I didn't write that here. C, x goes to c. Okay, and what you, x minus 2, and what you're going to get out is a number. What you're going to get out is a number, because f prime of 2 is a number. But then, so this will be a. Calculate this, get what you get. Now, I have to find the derivative of negative 2. Oh boy. So now you do f prime of negative 2 is the limit, so that's my c. The limit is x goes to c of f of x minus f for c, which is negative 2, divided by x minus c. And you calculate that limit. Like, this equals a number. Calculate that limit. You're like, boy, oh boy, this definition stuff is brutal. And then, if you choose to use the alternate formula to find f prime is 7, so c is 7. I'm going to say c, but I'm going to write 7. The limit as x goes to c of f of x minus f of c over x minus c. And here we get a third number. You did this limit 3 different times. I would not do this. What I would do is, if I was asked to find the derivative at 3 different values, what I would do is I would use the regular definition. I would say f prime of x is equal to a limit as delta x goes to 0. No, let me not even write that. Alright, I'll write it. F of x plus delta x, etc. Delta x minus f of x over delta x. And what we are going to get is a function of x, just like we said we would get. Here, we said we're going to find the derivative at 2. Well, the derivative is a function of x, and when you plug in 2, you get a number. Now, armed with this function of x, so, maybe it's x squared minus 7x, or who knows. So now, I only did a limit on, let me write equals. So I did this limit 1 time. And I got my f of x. Maybe it's that function, maybe it's not. So now I plug in 2 into the result of this limit, my function of x, maybe in that formula, and I'm done. And then for b, f prime of negative 2, I evaluate my derivative at negative 2, I get my number, and then f prime is 7. I plug in 7 until my function of x, plug in 7 for x, and I get back a number. So in the top part, up here, I did 3 limits, and after the limit, I had my answer. Here, I just do 1 limit, and then I do 3 evaluations. That's a lot easier. If I was given a function, so I guess I might say given f of x, and I was asked to find f of many numbers, many in this case I think is more than 1, I would not use the alternate definition. I would use the standard definition get my f prime of x, plug 2 in, work it out, plug negative 2 in, then 7. However, if I was asked to find, so you're given f of x, and the problem says find f prime of 11. That is, just find f prime of one number. Well, I have two methods of doing this. I can find f prime of x by calculating this limit. I calculate this limit, and as it says, I get a function of x, and then I evaluate f prime of 11. So I do a limit and an evaluation if I use this definition. However, again, I only want to find f of one number. Now, if I only want to find f of one number, I can go for it all in one step. Do one limit and have the answer. I do the limit, so that's c. I do the limit. I'm going to use the alternate definition. The limit as x goes to c, f of x minus f of c, which is 11, f of x minus f of c, all over x minus c, and I'm done, where c is 11. And I'm done. Done. Because I'm going to have f prime of 11. I just want to do one example. Suppose that f of x is equal to x squared, and we want to find f prime of 5. If you remember, I said that the derivative is 2x, so we should double this and get 11. Right. So, by definition, f prime of 5 is the limit, or f prime of c is the limit as x goes to c of f of x minus f of c over x minus c, where c is 5. Okay. So this is equal to, the limit is x goes to 5, well, f of x is x squared. F of 5, well, f of this is this squared. That is f squared, what goes in there. So if they put 5 in there, I'm going to square it over x minus 5. Now, I can factor the numerator to x plus 5 times x minus 5 over x minus 5. Now, this fraction is not always 1. Top and bottom are the same, but it's not always 1. When x is 5, this is going to be 0 over 0. Just the purple. Okay? And I can't cross that out and call it 1 if it's 0 over 0, but it's only 0 over 0 when x is 5. Oh, look at how lucky we are. X is never going to be 5. It's going to get really close to 5. It'll never, ever, ever be 5. Then maybe x will be 5.0001, close to 5. So I'm just going to copy down what's in purple. Minus 5 divided by x, which is really, really close to our 5, minus 5. So when you have this number and you take away 5, you take away the 5, you just get the decimal. 0.0001, same exact thing for the denominator, and this is 1. Only 0 over 0 is 1. Isn't 1. I don't care how small you are or how big you are. I couldn't care how small you are if you divide it by the same thing. And no promises I'm putting the same number of zeros, but assume I did. This is 1. Okay, so what happened is what's in purple does cancel out to 1 because x is not 5. So what I get is the limit as x goes to not 0 but 5 of what survived, x plus 5. Now that I am directly substituting the value that x is approaching, I no longer write limit. X becomes 5. 5 plus 5 is 10. And that's exactly what we said we get. Just double 5. Okay, now I'm not going to do this. So notice I calculated this limit and I got exactly what f prime of 5 was. Now, if I had calculated f prime of x using the regular definition, which I'm not going to do all the work, after a few lines, you will get this as 2x. And this took as much work, getting to the 2x, took as much work as it took for me to get this limit to equal 10. Exact same amount of work. But now I have to do more. I have f prime of x. So now I have to do a little bit more work. I have to find a derivative at 5. The rule for f prime of x, that is, what does f prime do to what's in the brackets? It doubles it. Fine, it doubles it. I'll double 5 and I get 10. This is a little bit more work, okay? But definitely, if you need the prime, find f prime of 3 and f prime of 11 and f prime of pi and f prime of e to the pi. Do not use this rule. Use this rule. Because then all you have to do is double. This is going to be 2 times 3. You do the math. This is going to equal to 2 times 11. This is going to equal to 2 times pi. And this is going to equal 2 times e to the pi. Okay? Now, again, I just want to stress this. If you calculated f prime of 3 using the alternate formula, you would get 6. And then you would have to veer a limit. Then you'd have to do the limit again to get 22 and so on. You don't want to do that. Okay, that completes the derivation of the alternate derivative and some more.